All right, this is part of the video series for what we talked about, which was that because we are not going to have a physical class meeting on May 2nd due to graduation commencements, ceremonies and things, I am recording the 10.1 to 10.3 notes. Now, this first video, just to keep things smaller and more manageable, is just over 10.1 and 10.2 because that is one homework assignment. And the second one will be over the 10.3. So we're looking at graphing data and looking at just data essentially in visual formats versus also analyzing data and finding quantitative or numerical ways to talk about the data. So just a couple things we want to go over first is just different types of visual representations of graphing data. So we have what are called bar graphs that are widely used because they are easy to construct and interpret. They are effective in presenting visual representations or comparisons of data. So let's look at a couple of these. And notice all visual data should have a title that tells you what the data represented in the graph is, and they should have labeled their X and Y axis. So it says passengers boarding at the busiest US airports in 2015. We have boardings, and notice this is in millions of passengers. So that'd be 0 million passengers, 10 million, 20 million, 30 million, 40 million, and 50 million. We've got different hubs or big airport locations, which is New York, Dallas, Fort Worth, Los Angeles, Chicago, O'Hare, and Atlanta. Now, what we can see, and this is a big important thing on looking at visual data. You want to make sure that the scale helps us see visually the differences between different cities, essentially. So notice they counted by tens. They didn't change that scale. They kept it consistent the whole way across. And notice we can see that Atlanta has the highest number of boardings, so it's one of the busiest in 2015. And New York was less busy. Now, it doesn't mean it's the least busiest airport in the US. These were just some of the big ones. So we can definitely make comparisons between the two. We can actually say that Chicago and Los Angeles during that time were about boarding the same amount, and we could guesstimate that maybe to be around, it's a little over half, so maybe 36 million, 37 million passengers. Okay, look at our second graph right here. This is the US public debt, and they've got the years from 1975 up to 2015, and notice we are counting by tens, so every jump is an equal kind of jump, not just different jumps like 1 year to 5 years. It's 10 years each time. We have billions of dollars in the public debt. So we had 5 billion, no, sorry, it looks like that's 5,000 billion. Yeah, 10,000 billion, 15,000 billions, and 20,000 billions. So, which means we're actually in the trillions. This would, because once you have a group of three, you kind of move up to the next counting system. So this is a weird way. If I was doing this graph myself, since everything was kind of already in the trillions, I probably would have labeled that as $1 trillion. But again, this is a good thing to see because it talks to us about how do we best represent that information. And you can see that it's been a huge, huge leap in the debt. Especially from the year 2005 to 2015, we had an extreme increase in the debt for the US, whereas we were still increasing debt, but it was more of a consistent growth before. It was slightly getting bigger in the differences of the heights, but this was a huge change. And then we also have these type where you have what are called comparative bar graphs. These are when you have two different subcategories side by side. So notice this is education and income in 2014. So we have our median annual income. Notice these are just in regular thousands of dollars. They didn't give us any other notification. We had different levels of education, some high school diploma, some college associate's degree and bachelor's degree. And then we actually had males as the blue bars in each part, and females represented as the red part. So notice there is, there's things we can state. We can say that from 2014, across all levels of education, males were making more than females, even though they had the same level of education. We can actually talk about differences. Now, this is different because we have comparisons within two groups. So like say right here, let's look at associate's degree, because a lot of you are going to Ivy Tech and you're going to get an associate's degree, maybe before you move on to get that bachelor's. So if we follow down these numbers, so let's follow it down best we can. I'm kind of estimating. For associate's degree, I'm just going to write out some notes. and female, it looks like, and we're going to estimate this because we can't tell exactly. We're looking at maybe, so this is about the halfway point, that'd be 35,000, maybe $38,000, just a rough estimate. Males for that same level of education, follow this down. Best we can. It's kind of hard to drop it down without a ruler. And we're looking at maybe roughly 51 or 52. You can kind of be close on either of those estimates. Okay. Now we can tell that information. So we can actually give an actual difference between the two. This is actually called the absolute change. We talk about that in quantitative reasoning classes. So the difference between the two just means, and I usually do the higher one minus the lower one. So 51,000 minus 38,000. And that we can then say how much more cash-wise the males were making compared to the females, since the females were doing second in the subtraction problem. So notice that is 13,000. So we could say the males at that time and with the associate's degree were making 13,000 more than the females at that time and in that level of education. Then we could also do what's called a percent increase or decrease, and I'll show you how to do that. Now, it is going to matter which direction they word the problem. So if they say, like, if you are supposed to do a percent increase or decrease, and they say from the males to the females, whatever the one that follows the word from, that is going to be the second part when you subtract. So we'd actually have to reverse this if we were saying from male to female, because we would be doing, we would be saying actually from male to female is actually a decrease in pay. So it would actually be a negative. So if we do, I'm going to do it the way we've already got this, so we can use this. So if we do from the female to the male perspective, that means the female is the initial starting amount. So that's the lower salary. The male is the ending salary amount. And we're actually going to compare that and see what percent growth there is between the two. So the way you do that is you do what we call new minus old divided by old. And in this regard, the from is always the old and the to is always the new. Okay. So again, this matches with how I subtracted up above. This would be 51,000 for the males minus 38,000. And then we divide by the old, which would be the female salary, the 38,000. Now, if you're doing from male to female, first of all, you'd reverse the order of the subtraction on top, and it would end up being we're losing money, we're going down in pay, and you don't divide by the same denominator. You divide by, if you're doing from male to female, you divide by the male salary, because percent change is based off of where you start. So we have 51,000 minus the 38,000, and then divide that by the female salary, since we're starting from female and growing to the male salary to compare them. And we would usually round this to maybe 2 decimal places. So this is 0.34, or we could say it's a 34% increase from the female salary to the male salary. Okay, so that's how you can use those when you have especially comparative bar graphs like this, where you can get values for both. You can do a little bit more discussion. You can talk about the difference between two values using the rough estimates of what you think those are falling out. Obviously, we're estimating, and then we can find percent increase or decrease. So that's a nice way to use that information. We also have what's called a broken line graph, which can be obtained by getting your bar graph and just finding the midpoint of the top of each bar. So notice they just found the middle of the top of each bar. Each bar has an equal width. And then we just make what we call broken line graph by connecting these little mini segments together. Okay, so that's how you make a broken line graph. And a lot of times what they'll do is they'll actually remove the bars afterwards. And so you'll just see the line graph. Now, a special type of bar graph that we actually will show you how to create, this is one we will do together, is called the histogram. And it's a special kind of vertical bar graph that represents numerical data. They have no spaces between the bars. So notice I have to use what are called boundaries. And notice these are like half points. And it is hard to see, but this one goes with that one. They kind of had to stagger them to get the picture to show up nicely. So I'm just kind of drawing those lines in. But it looks like essentially they're going up by 50 points. So each of these, if you subtract one endpoint minus the beginning endpoint, you'll notice that they all have a width of 50. They're all equally spaced like that, width of 50 all the way across. So when we look, and actually I'll write this out to the side, when we create these, we're going to be telling someone what is the frequency of occurrences. So notice that these are entrance examination scores, and they have two different ways you could do it. You can do the frequencies, or you can do it as a relative frequency. That does not always necessarily turn into point, whatever this value is. You have to know how many elements you have. The assumption here would be that we had 100 items total, because they are saying 200 divided by, or 20 divided by 100 is 2.2. So I'll show you when we recreate ours. We just have to make sure our percentages that we get for our relative frequencies are represented on the bar line. So you can do it either way. You can either list frequencies, or you can turn those frequencies by dividing by the number of elements you had into specific relative frequencies or their decimal form. So we're going to show you how to do that in just a second. But anyways, you can actually kind of guesstimate what the height of these are. So that may be 2, that one's 5, that looks like it's 10. This might be 22 or 21. This is 20. This looks like maybe 19 or 18. Again, we have to kind of guesstimate. This may be 11. This one may be maybe 7. It's a little higher than where I think the 6 would be. And then maybe this one is at 4. Okay. Now I'm just rough eyeballing that based on the frequency part out here. And what this means is if you had the list of data in front of you, all of the data, and you actually go through and say, okay, how many numbers did I have between 299.5 and 349.5? We would have only had one number in our list of data that fit that characteristic or that group. Now, a lot of times, like I said, these are boundaries, because we don't want to have a number here. Like we don't want to, we usually use like half steps, these 0.5s, because if our number was 599, we don't want to be confused about where it goes. It would go to the left, since that would be less than 599.5. So a lot of times our values will be integers, and we will use these half intervals, essentially kind of to use on a 0.5 to make it distinguishable, so that none of our integers fall in like 2 bars at the same time. They're all going to be in distinct bars. And then, like I said, we're going to try and practice doing this on our own. So this is a collection of the entrance exam scores for the 100 entering freshmen at Large University. And we want to complete the frequency table. So I'm going to show you how to do that. And then we're going to turn those. So we're going to tallies first. That's just so we don't go crazy looking at all these numbers. There's 100 numbers here. Then we're going to do frequencies, which is how many are in each group. Then we'll have the relative frequency as a decimal. That just means you take how many you had in each group divided by the total number of numbers, which here is 100, and that will be our decimal form. Okay. Now, because this is a tedious process, I'm only going to show on camera me filling in these first 2 columns, and then I'm going to pause and I'll fill in the rest of the tallies. You can practice doing that on your own. You just go number by number, find its location, you make a tally mark. And that way we won't spend a ton of time staring at this. So 762 is our first element, and that's going to fall into this last group from 749.5 to 799.5. So I'm going to make a mark there, just a little tally mark. I usually mark the number off up here so I know I used it. 433 is going to be between 399.5 and 449.5. 712 is going to be between 699.5 and 749.5. 566 is going to be between 549.5 and 599.5. 618 is going to be between 599.5 and 649.5. So I'm just trying to find the location for each number. 340 is going to be between 299.5 and 349.5. 548 is going to be right here, 499.5 to 549.5. It has to be less than 549. And then 442 is going to be in the 399.5 to 449.5. 663 is going to be in the 649.5 to 699.5 range. And 544 is in the 499.5 to 549.5. And actually, I think you probably get the gist here. I could do the second column as well, but essentially we just go column by column and we are literally just finding where does each number fall in these intervals. These are called our class intervals. They tell us what makes up a bar in our histogram, essentially. We go from this X value to this X value. And so I'm going to pause real quick and fill in the rest of these tallies. I did this off screen already anyways, and then we'll convert them to frequency numbers, which is really easy, and then the relative frequencies. So let me pause real quick. Okay, so I finished out those and I did all the new tallies in black just so you could see if you look back at the notes that the red ones I tracked up here, and I then just worked out all the rest of them off camera. So what we do to tell how many, and notice there's a bar, a diagonal bar, anytime I got 5. So 1, 2, 3, 4, and the 5th one is a diagonal. That's just so you can easily see and count by 5s. But we essentially, the frequencies is just the number of elements that were in each group. So that's a 1, a 2. This group will be a 5. This is 10. 5, 10, 15, 20, 21. 5, 10, 15, 20. 5, 10, 15, and then 4 more, so that'd be 19 items. 5, 10, one more would be 11. 5, 6, 7, and 4. Now, this graph that I already had on here actually is this, and I think I got pretty close to guesstimating them correct. I said 1, 2, 5, 10, 21. 1, 2, 5, 10, 21, and then I had 20, 19, 11, 7, and 4. So 20, 19, 11, 7, 4. I did really great. That's not always going to happen. It's not always easy to kind of perfectly guesstimate where the frequencies are going to fall, especially if they have, you know, a large gap in their scale. But we did really good with that. So now that is the frequencies, and we got that from looking at the whole list of data and then just making a tally for the class intervals. Now, in your homework, you're going to be given the class interval in a certain way, and I'll show you in a minute how to do that. They kind of tell you what width to make your histogram intervals, or your bar width, essentially. And then they tell you what value to start with. So I'll show you in one of our next examples coming up how to create that. But before we do that, let's make sure we know how to do a relative frequency. So relative frequency means you need to know the total number of items. So if you add up this frequency column, they also told us at the beginning, this adds up to 100. So each of these number of items in that specific group gets put over 100. That's our total frequency. You divide that on your calculator and you write it in decimal form. Now, because it's over 100, that's why I told you on that graph we just looked at, it's kind of deceptive a little bit because we always got the same decimal value that we look like we had for our frequencies. That's because you're dividing by 100. If you had a number of items was 50, these would look different. They wouldn't match with the frequency part. So that is something to be aware of. So 10 divided by 100 would be 0.10. 21 divided by 100, if you check on your calculator, should be 0.21. 20 divided by 100 is 0.20. 19 divided by 100 is 0.19. 11 divided by 100 is 0.11. 7 divided by 100 is 0.07. And 4 divided by 100 is 0.04. Because we're dividing by 100, we essentially just are going from a percent form, because percent is out of 100, to its decimal form. All right, so determine the probability that the score is between. So probability would be the decimal form, because we don't want to use, or you could use the fraction, I guess, but most of the time, if you've already converted it to decimal, we'll just report the decimal. So we want to be a probability that the score is between 499 and 549. So no, I know that 499 shows up on both of these, but they're saying we want to be between these two. So this is the bar that they're talking about. So that probability is that row decimal answer, which is 0.21. For the next one, we're looking at what's the probability that we're between 449 and 649.5. So that's more than one. That's this region all the way down to this one. So notice this is the lowest boundary up to the highest boundary. So we would need to add all of the probabilities for those 4 rows. So that's 0.10 plus 0.21 plus 0.20 plus 0.19. And I believe if you double check me on your calculator, that should equal to 0.70. So there is that probability. Okay, so now we're going to do one from scratch. We're actually going to take a set of data. It's not as long or big. It's 20 graduates this time. This is their starting salaries in thousands of dollars. So that 44 actually represents $44,000. They're just shorthanding and telling us that it's in thousands of dollars. And we're going to have to create the class intervals ourselves, do the tally real quick, which shouldn't take as long, do the frequencies, and then this time they want the relative frequencies as simplified fractions. That's just how they asked for it, so we're going to provide them in that format. Now, notice that the directions on the frequency and relative frequency table says we're going to have a class interval width of 4 starting at 30.5. This is the first thing you need to focus on. So you're going to put a 30.5 on that specific opening of that interval. Now, a lot of times people don't use the class width correctly. It tells you between the start of this interval and the start of the next interval, we need to have a difference or adding an additional 4 units. So you use your class width to start with your first width interval, or your interval starting position, I should say. And then you need to continually add 4 to get the starting position of each next class interval. So this would be 34.5. We add 4 again. It's going to be 38.5. We add 4 again. We're going to get 42.5. Add 4 again, we get 46.5. Add 4 again, we get 50.5. Okay. Now, the way we do this is, remember, these are half steps because none of these are half steps up here. This is all integers. So it is okay to have our first interval also end with the 34.5 because that is not a possible salary where we would have somebody being in both intervals at the same time. This is a boundary number. Okay. So each of these is just going to have the beginning of that interval is the end of this interval. Now, that is done sometimes slightly different in statistics classes. It just depends on how they define the parameters of the problem. But for us, this is how we'll do it. And then this is 50.5. Now, notice these are all increasing by 4 as well. So this last class width, you want to add 4, just like we added 4 to all the other parts. Okay. But technically, the class width should tell you how to jump from the beginning of one interval to the beginning of the next interval. So that's how you use that 4. Okay, so now let's get our tallies. So 44, I'm just going to mark them off as we go, is in this one right here, 42.5 to 46.5. 39 is going to be in 38.5 to 42.5. The 37 is in this group. 49 is in this group. 51 is in the last group. 38 is actually in the second group because it's up to 38.5. 42 is in the third group. 47 is in the next to the last group. 45 is in the 42.5 to 46.5. 46 is also in that group. 33 is in the first group. 41 is in the 38.5 to 42.5 group. 43 is in the next group under that. So is 44, and that's going to be our 5th element. So I'm going to go ahead and make a tally diagonal. 39 is going to be in this group right here, the 3rd one down. 37 is in the 2nd group. 45 is in this group again. 39 is in this group, so that makes 5 for that. 40 is also in that group. And so is 42. Okay, so what we've got is if there's 1 element in the first class interval, there are 3 elements in the second class interval, there are 7 elements in the third class interval, 6 in the fourth, 2 in the fifth, and 1 element in the last interval. And you double check this to make sure you get your 20 students or your 20 graduates. So we add those together, make sure that adds to 20. Now we want to write these as their fraction form instead of decimal. So this would be 1 out of 20. So 1 of the 20 are in the group 1. 3 out of 20 is in the second group. 7 out of 20 is in the third group. I get to this one and I do need to reduce because they did say simplified fraction. So we can divide both of these by 2. So that'll be 3 out of 10. 2 out of 20 also reduces to 1 out of 10. And then we have a 1 out of 20. Okay, so there's all my relative frequencies as reduced fractions. Now we're going to construct the histogram using our table. So I'm going to make kind of it's like a quadrant 1 graph because you only have your X and Y axis. Everything's positive. We've got that our class intervals were their salaries, and those were listed in thousands of dollars. Just abbreviate that. The y-axis is always frequency when you're doing the histogram, or relative frequency. But since they asked me for the relative frequencies in fraction form, I really don't want to deal with that. I'm going to use frequencies. The highest frequency we had was 7, so I would probably just count by ones and make this equally spaced. So 1, 2, 3, 4, 5, 6, 7. My X values down here, you want to kind of equally space them, but we don't start from 0 to 1. We're kind of making a jump down the graph. This is called a line break or a graph break. It just means we're not starting right directly at the natural first jump from 0. We're kind of zooming in down the line. So our first interval needs to start with that 30.5, and we're just going to equally space these. Remember, they're going up by 4. So 34.5. 38.5, 42.5, 46.5, 50.5, and 54.5. Now, when you draw your histogram, oh, and we also need a title. So this is the salaries of the graduates that they were measuring, okay? So when you start your histogram, you start with the lower end of that boundary. You go up to the height that you need to go to. So for this first one, it was 1. You draw the bar over until you reach where the second interval is going to start. And we draw that down. So that makes that first bar. The next bar is going to pick up, and we're going to have that as our same line, but we're going up to 3 this time because there were 3 items in that group. Follow the bar over till you find you're right above that next interval, and then you draw it down. Then we had a height of 7. So 7 items were in the next group. Always harder to draw these and make them look even rectangles. Mine usually end up looking wobbly. The next group, there were 6 items in that group from 42.5 to 46.5. Then we had 2 items in the next to the last group. Oops. I'm gonna go far enough. And then we had 1 item in the last group. So notice there's my histogram. And this is a mostly symmetric histogram. It's kind of looks like a mound or a hill, okay? Now, what question they had down here is kind of hard because this doesn't correlate directly with the values of the endpoints. They said, what is the probability that a graduate chosen from the sample will have a starting salary greater than or equal to 40,000? But we have the list of data, so we just need to find any salaries that are 40 plus, okay? So if we go up here, I'm going to circle them. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So out of all 20 graduate salaries, 13 out of 20 of them had a salary that was greater than or equal to 40K. Okay. And we can leave that in fraction form since they didn't have us go to decimals, but you could also, if you wanted to talk about it as a percent, which they didn't say that, they said probability. If you divide that, you can get the decimal and then convert it to a percentage. Okay. So that leads us into the 10.2 part, which is measures of central tendency. So this first section was all about graphing and visualizing it. Now we're going to be talking about what if I don't want to graph the data and I just want to talk about some typical values that help me see kind of where the center of my distribution are. That's why they're called the measures of central tendency. You've probably heard of these 3 before. They are mean, median, and mode. So let's just review kind of what they are. The mean is what you typically think of as an average. It's the sum of all the values divided by the number of values you have. It is very strongly affected by outliers. If you had everybody making, A's in a class, but then 2 people don't show up to take the test and they make a 0, you're going to have that average. If you add everybody's scores together and divide by how many you have, you're going to have that average being brought down a little bit because of the 2 people who made the zeros. That's a very, very outlier compared to everybody else making like an A. Okay. Population mean is and it uses that little Greek symbol mu, that's what that's called, this one right here, if the data set contains your entire population. So you can only write this symbol if you know you have all the data for the entire population you are studying. That's not as easy to come by. Sample mean, which we write as X bar, so it's an X with a bar above it, is if your data is from a sample. So you collect some data from, say, some students at a high school, but not all of them, but you want to talk about the whole high school in general, you have a sample from your population. okay? The median is the middle value in a set when the data are put into ascending order. That means from least to greatest. So in case you don't remember what that means, I'll write that in. So least to greatest. If there is an even number of values, you got to be careful about the median because there are two numbers in the middle, and we're actually going to average them and find out what is in between, what is halfway between the two middle numbers. If you have an odd set of data, you will have one element from your list that is in the exact center. This is also called the 50th percentile because if you're in the dead center of the data, 50% of the data is to the left of you and 50% of the data is to the right of you. It's the dead middle. It is not affected by outliers. It doesn't matter how high or low those ends get as long as we can find the center. And then the mode, a lot of people remember mode by the word most. It's the value that is the most frequent. So it has the highest frequency or highest repetition of a set of data. It is not affected by outliers either. It is the only measure that can be used for non-numerical data. So there's one specific homework question that talks about colors of cars. You'll see it when you do your homework. You can't find a mean and median for that specific problem because all of the data is based on what color the car is. That's not, they're just telling you how many people have a blue car or a black car. You can't find a mean or a median for that because the data is colors, not numbers. So with that situation, the only thing that would be usable would be a mode. You could say which color was owned the most. So that's something to be aware of. You can have no mode if every item in your data set only occurs once. You don't have anything that has more frequency than anything else. So you can have no mode. You can have a single mode, which is one item that occurs the most. Or you could have two or more modes. If you have a bunch of numbers that all occur the most frequent and they all occur the same number of times, so say they all occur 3 times, all of those numbers that all occur the most frequently, they would each be modes for that set of data. So this is the one that has a lot of flexibility. So we're going to do a small example. We have 15 customers filled out a satisfaction survey, which was rating the service they received by checking a number from 1 to 5. So just a survey with 1 to 5, probably 1 is bad service, up to 5, which is great service. We want to find the mean, median, and mode of the ratings below. So notice we can find the mean, median, and mode because the data set is all numerical. These are actual responses that people gave. They circled those numbers. The first thing I do in any set like this is I go ahead and reorder it because I'm going to need it ordered for the median. Okay. So what I do is I just find the smallest number, put it in front, and I mark it out as I go from the original list. So I know I don't miss anything or double count something I shouldn't have. So we had 1, 2. For 3s, we have 1, 2, it looks like. So I'll have a 3 and then a 3. So that's 2 3s are gone. For 4s, I have 1, 2, 3, 4, 5. So I need 5 4s. So 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Notice I'm double checking. And I have 1, 2, 3, 4, 5, 6, 7, 5. So notice I'm trying to keep them kind of equally spaced with the list they originally gave me because that helps me see if I have all the numbers that I'm supposed to. Okay. Another thing you can double check is see how many elements you had, which was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, which matches with the customers they told me we had. And then just double check you have 15 in your list. Okay. So now we're going to do the mean. Now I am going to grab my calculator for this part and share it. X bar, since this is a sample, we don't know all customers that they've ever dealt with. We just have a sample of them. We are going to add up all the values. So I'm just going to write that in my numerator. And I will show you a shortcut to do this a little quicker because a lot of these elements are repeated. But let me show you the traditional way first. So we have 7 5s. So 1, 2, 3, 4, 5, 6, 7. Did I do too many? 1, 2, 3, 4, 5, 6, 7. No, that's right. And then we had 15 items total. Okay. Now, another way of writing this top is because you have repetitions, you can say I have 1, 2, plus I have 2 3s. You're just telling me how many you have because 3 plus 3 is 6 and 2 times 3 is 6. We have 5 4s. So I'm going to say I have 5 4s, which we know should add to 20. And then we had 7 5s. So this just, it's kind of a way of doing a weighted average. You're just telling me the number of repetitions. So instead of pushing add a bunch of times on my calculator, I'm kind of using multiplication of the repetition of addition to get to the answer a little quicker. So that would be a 2 plus a 6 plus a 20 plus a 35 if I have all my multiplication done. So that is 63 over 15, and we divide that to go ahead and get the average. So this mean, the bar, is approximately, actually it is exactly. We only put approximately if we have to round it. But I believe, let me double check my calculator. It only had one decimal place. Yeah. So it is a mean of 4.2. Okay. The median. All right, the median is the middle. So since you have 15 items, we have an odd set. I usually make a note of that. So I have an odd number of items. So that means there should be one number in the middle, and I've already ordered this from least to greatest. So since it's 15, you can just count, half of 15 is 7.5. So we're going to be using the the eighth number in the list. You have to round that up. So 1, 2, 3, 4, 5, 6, 7, 8. Notice you can double check that this is the middle by there should be the same number of items to the left as there are to the right. We have 1, 2, 3, 4, 5, 6, 7 items to the left. 1, 2, 3, 4, 5, 6, 7 items to the right. So my median is 4. And then for my mode, well, you just have to tell me which number was repeated the most. And that is also in my little simplified mean up here. The 5 was 7 times. So the element 5 is the mode. And it is the only mode. 4 is not the same because even though it has a lot of repetitions, it's not the most repeated item. All right, let's do another one of these. So it says find the mean, median, and mode of the listed numbers round to one decimal place. So I have the mean and the median and the mode. I'm going to find all of those. And I'm going to put these in order from least to greatest again. So 30 looks like the smallest number. I don't see any other numbers that start with 3. For 40, the smallest thing I see is 42. So I'm marking them off as I go. Next smallest 40 is the 45. It was already in the right position. I have two 46s. So I'm going to write both of those and then mark them both out. I don't have any other 4s. The next biggest thing is a 52. Then I have a 56. I have two 67s. And I have a 72. Okay. All right. So to get the mean, we take there's not many repetitions of items, so it won't be, I mean, you can still write the shorthand like I did. You would just say, I have 130 plus 142 plus 145 plus two 46s. So it only helps you with a couple of items. So I would probably just write this one out and show my work. We're adding all the elements together. And we have a total of 10 items if you count how many you started with. So this numerator, when I added all that up, was 523 divided by 10. So I get a mean score, and I don't need to round it because it comes exactly to the one decimal place. So 52.3, that's my mean. Okay. My median. Now, since I have 10 items, we're going to have to split the two middle items because you can't just say, because if you divide 10 by 2, you get 5, which means you have exactly 5 elements to the left and 5 elements to the right. So if you look right here, this is the point where the median would be. It would be halfway between 46 and 52 because I have 1, 2, 3, 4, 5 numbers to the left, 1, 2, 3, 4, 5 numbers to the right. To find the median, you're looking for what is halfway between those two numbers. These two numbers are not the actual median. They're helping us figure out the halfway point. This is called finding a midpoint, essentially. So we do 46 plus 52 divided by 2, and that'll tell us the location of the median. Even though it's not a data point for us, it is the halfway point in that between the two middle numbers. So 46 plus 52 is 98 divided by 2, and we're going to get 49. So there's my median. Now I have two modes in this specific problem. We have two 46s, but we also have exactly two 67s. So this is what I meant by sometimes you can have more than one mode. They both are modes because they both occur more frequently than any of the other numbers, and they also occur the same amount of frequency. So if I'd had, 3 46s and 3 67s, and I had two 72s, the two modes would still only be 46 and 67 because 72 didn't occur as frequently as those. So you just have to make sure you're finding the most frequent. All right, so let's look at the next page. It says, when we're computing the mean and median of grouped data, that's those intervals that we were doing, the class intervals. Unfortunately for us, when you see this, a chart like this, if this is what's given to you, you don't know the actual data set if you don't have that list in front of you. If I just have the frequency table and everything's in interval form over here, I don't know if these were all, this tells me I have 4 items that were in this interval. They could have all been 4s, they could have all been 5s. 2 of them could be 3.8 and the other 2 could be 5.2. We have no idea what the 4 items in the data set actually were. We just know they occurred between 3.5 and 5.5. So that makes for a little more complex way of finding the mean and the median. So we're going to have some formulas for how to do this. So we have to estimate a bit if we do not have access to the original data set. For the mean, we will find a weighted average using the that's supposed to say midpoint, not midterm. The midpoint of each class to represent all the members of that class. The mean represents the balance point of a histogram. And then for the median, we'll have to find the 50th percentile, or the value that splits the left and right area to be equal. Now that's kind of hard to visualize sometimes because these heights of bars are all different, but their bar width is at least the same. So we're going to be able to use that to our advantage. So we'll have to use some things we know about area to be able to find the median as an estimate. Okay. So let me write you the formula for how you find the mean when your data is grouped like this, when you have a frequency table with intervals instead of exact data. The first thing you're going to do is you're going to find the midpoint of each of these intervals. Now, I'm going to show the work for one of them, and then I'm going to show you a nice thing about this. Notice this has a class width. If you look from here to here, the class width is a 2. Because if you notice, if you add 2 to each beginning, that gets you the beginning of the next group. So our class width is always 2. So to find that midpoint of that first group, you take the start and the end of that interval and you add them together and you cut them in half. Essentially, you're finding the middle, just like we did when we did the median of 2 numbers. So 3.5 plus 5.5 is a 9, divided by 2 is 4.5. Now, some people can visualize that and say, oh, well, halfway is exactly 4.5. But that's how you do it mathematically. Now, here's the fun thing. Whatever the class width is, your midpoint will follow that rule as well. So if we keep adding 2, notice 6.5 is halfway between these two. Add 2, 8.5 is halfway between these two. Add 2, we get 10.5. Add 2, we get 12.5. Add 2, we get 14.5. So these are all my midpoints. They're the middle value in my class interval. So it's kind of like the middle point of that histogram, okay, for each bar. All right, so the big deal about this is that this is why we are estimating, not getting an exact mean. So for the mean of grouped data, we're going to follow this generic kind of formula. Okay, you're going to say your X bar is equal to this symbol in math. It's called the sum. Okay, and they usually use like from I equals 1 to n. That just means add all of your interval elements from the first one to the last one. That's all that means. So we're going to sum up. And what we're going to do is take our midpoint. That's what this guy is for each interval. And we're going to times it by the frequency. How many of them were there for each interval? So you do midpoint times frequency, midpoint times frequency, midpoint times frequency. You do that for all of them. Then we add them all together because it's a sum. And then we divide by the total number of frequencies. That's what our n is. Okay. So for this, before I can even get started, I need to know the total frequency or I won't know what my n is. So this is 6 plus 8, so that'd be 14, plus 4 more is 18, plus 3 is 21. So that's an n of 21. Okay, so at least I know my denominator. Now, across the top of my fraction, I'm going to do midpoint times how many were in that group. So that's 4 plus midpoint, which is 6.5, times how many were in that group, which is 2, plus midpoint, which is 8.5, times how many are in that group, which is 3, plus midpoint, which is 10.5,
times the number of elements in that group, which is 5, plus midpoint, which is 12.5 times there are 4 of them. And then last plus, I'm kind of running out of room. We have 14.5, and that one is times 3. Okay, and then we're going to divide all that by 21. Okay, so when I did the multiplication of each of these parts, so I'm just going to write out my multiplication step. I got an 18 plus a 13 plus a 25.5 plus a 52.5 plus a 50 and plus a 43.5. So notice that's multiplying 4.5 times 4, 6.5 times 2, and so on. If I add all those together, I get 202.5 for my numerator divided by 21. Round that to 2 decimal places, and we'll get that our mean of our group of data is approximately 9.64. So I'm going to double check that I did my division correctly. Yeah, 9.64 would be the rounded answer. So notice that this is not a perfect mean. It's not the exact mean because we did not know what the 5 numbers actually were in the interval from 9.5 to 11.5. Essentially, what we're doing here is we're making them all 10.5 and using that middle value as a kind of estimator, okay? Now, the median is a little different, okay? So to find the median of grouped data, let me highlight that. This is the mean of grouped data. Now we're going to find how to do the median of grouped data. This one's a little trickier. Okay, so let me highlight that so it also stands out on the page. Okay, so with this, I'm going to type in some information just because it's better than my handwriting. So the median for grouped data, I can type, with no classes of frequency 0. Now that is important. All of our classes up in that group had something in each class. Otherwise, this would be a little tricky to do this way. Is the number such that the histogram has the same area to the left of the median as to the right? Okay, I got histro instead of histo. Fix that. Okay, so what does that mean? Well, essentially what we need to first do is draw the histogram and look at the area involved. Because when we say we want to make sure that we have the same area to the left and right, we need to visualize the area. So I'm going to draw a histogram for that specific data table that we had up above. And we're going to talk about the area. So one, we're going to draw the histogram. Now, a lot of these on your My Math Lab, they'll just give you a multiple choice of which histogram it is, and you pick the right one, but you should know how to do it yourself. So we have our intervals down here. They started with the lowest value of 3.5. So I have a little line break, 3.5, and then we were counting by twos, essentially, 5.5, 7.5, 9.5, 11.5, 13.5, and 15.5. The highest frequency we had was a 5, so I'm just going to count by ones. So I have a 1, a 2, 3, 4, 5, and you could keep going if you wanted to, 6, whatever. Okay, let's draw these out. So the first bar had 4 items, so I'm going to make this different color. So we go up to a height of 4, come over, go down to the next interval line. Remember, this represents frequencies. The next item in our list had a height of 2. There were 2 items represented by that group. So 2 all the way over. The next group had 3 items. So we have to go up a little more, go over, and go down. The next group had 5 items. So we're going to have to go the highest on this one. All the way up to 5, over, down. Then we had 4 items again for the next group. That was the frequency, and then 3. Now, you're thinking, why do I have to draw this histogram? Well, because we need to know where would we make the halfway point for the area. So part 2, we need to find the area
of the whole histogram. And then we're going to cut in half for the median. So we have to find it first. Then we'll say, oh, well, then I only need half of that area to figure out where the median is. Now, to find the area of the whole histogram, you have to go pretty much, I would say, bar by bar. And what you're doing is you're figuring out the area of it by doing its length times its width. Well, its width, which is this part right here, this is length, and this is width. You're finding area. We know that the class width is the same for each of these bars. Remember, because they had the class intervals jumping up by the same amount each time. The class width times the height or frequency of each bar equals the area for that one bar, okay? So for example, that first one is got a width of 2 because all of them have a width of 2. They're all 2 apart on the x-axis. But the height on that one was a 4. So the area of that first bar is an 8. So I'm going to actually fill this in with highlighted colors and we're going to write the areas, okay? So this guy gave me this bar. Okay. Actually, I might not want to color code it yet. And I'll tell you why in just a second. I'm gonna help color code to the halfway point. Okay. So you could do that, but I think it'll be easier if we save that for later. So this next bar is a width of 2, but it's also a height of 2. So it has an area of 4. The next one, again, the width is always 2 on these. So you could write these out 2 times a 2 because class width is always the same. This is a 2 times a 3. So that next one's going to have an area of 6. The next one goes up to 5. So that's width of 2, height of 5. So that's going to be a 10. The next one goes up to 4. So that's a 2 by 4 again. So that's an 8 because those notice have the same area. And then a 2 by 3 is another 6. Now, the total area is to add all of those together. That's for your whole histogram. So that would be 8 plus 4 plus 6 plus 10 plus 8 plus 6. That's going to be 20, 26, 34. Is that 42? Yeah, 42 is the total area. Okay. So that means the area to the median, that's what we're looking for, is the median should be half of that. So that is going to be 21. Now, why does that help us? Okay. So essentially, we're not always going to get lucky and say, oh, well, the median just so happens to magically be 9.5 or 7.5. It doesn't usually end up as one of our endpoints unless we get really lucky. We need to figure out which bar would we be in once we've had 21 accumulated items. So what that means is as you're going from left to right, notice there, if I just highlight this bar, I have 8 items in my list. If I highlight the next bar, now I have 8 plus 4. I have 12 items in my list. So I'm still not to 21 yet. If I add 12 plus 6, I'd be at 18. And then here's where things get a little dicey. And this is why we're going to have a formula next. When you go to add the next bar, you're going to go over your median. You're going to have, this was 18. If I add 10 to that, I'm at 28. So somewhere probably pretty close to the beginning of this bar. We don't know exactly yet. Somewhere in between 9.5 and 11.5. At that moment, somewhere in there, we have collected that element, the 21 element, okay? We'll still have 7 more elements to get all the way across the area of that whole bar. So the question becomes, what in the world is that X value right there? How do we find it? Okay, so we're going to call it actually our median, okay, M. So here is the last part, the formula, okay? So part 3. So you need the visual, though, to know what you're doing. We want to know the formula. So it's the area to the left of our median, which we know to be that half the total. That's what that is, okay? That's going to equal all the bars that we shaded in fully. So that's bar 8 area, the 4, and the 6. So all of those, we're adding those together. Then we have to do a special situation. We don't know how far we're going in to this bar. We do know we are going from 9.5 to something. So what we do is we say, okay, the class width for this last little mini rectangle is M, the median, because that's going to be somewhere in the part of this bar. We don't know where it is, minus the distance we went, which would be 9.5. So notice this little parentheses right here tells me from 9.5 to that M, how big is that? Okay. So notice our class width is not a 2 on this bar. It's not a full bar. And then we times that by the height of that bar. So this part always right here represents the class width of that mini rectangle that's not quite completely filled in. And this part is the frequency for that bar. Okay. So let's put in our numbers. So we know it's 21 equals, I would probably go ahead and add these together. That's 18. And then I would distribute this. This is 5M. And then we need to do 5 times a negative 9.5. It's going to be negative 47.5. We can go ahead and add the 18 and negative 47.5 together since they're both on the right side. So now I have 21 equals 5M minus, what was that, 29.5. We're just solving for M. We're solving for the median. We'll add the 29.5 over to the other side. So 21 plus 29.5. That's 50.5 divided by 5 because we got to get the M by itself. So notice the answer you get, if you're not getting something that's in between your interval 9.5 to 11.5, something was not set up correctly. So this is 10.1. So there's the median. So it is a lot more involved to find the median of a set of grouped data, but it's an intuitive process. It's what's my total area, which means what's my class width times the height of each of my frequency bars. How would I find the median or the middle of that? I cut that total area in half. That place, so I need to figure out how many bars would I need to add together to get close to that number, close to the 21. And then what the next bar, usually we have to go a little bit into it to actually reach the 21. Okay. Then we set up our equation. The area that's half of the total equals all the bars that we completely shaded in, plus, and then this is the tricky part. You have to say my midpoint is somewhere in from between 9.5 to 11.5. I don't know where it is, so I'm calling it M, minus the 9.5. That tells me how wide I went into my last little rectangle right there. That's the class width for that yellow shaded part. And then we times any of those, remember, class widths by the height or the frequency. So that's where the 5 comes from, because that's the height of that bar. Then we just solve that equation for M, and that is our grouped data median. Okay. So to finish out this set of notes, because we're going to have 10.3 on a separate video, I'm going to do 2 more of these grouped problems. One of them I'm going to do on the video. The other one I'm going to just do as the inked notes, and I'm going to post that. And then I'd love for you to try that one on your own, see if you're getting it right, and then check it against my inked notes. So we're just really going to do this one last one on the video part. And then, like I said, I will also write up this one when I post the ink version of the notes that will be right under the video and in the modules. And you can check yourself and see how you did. Okay. So we have to start with finding the midpoint of all of these, because you can't do a mean or median of a grouped data set, because notice these are intervals, not just one value. We can't find that unless we know those midpoints. So the best way to find a midpoint, remember, is to take the 2 endpoints that make the interval. We add them together and we say what's halfway. We cut it in half. So 799.5 plus 899.5. And then we divide that by 2. So this one is 849.5. Now, if you notice, these are widths of 100 because it takes 100 to go to the next group beginning on each one. So I already know my class width on all of these. For this guy, they're all 100. Okay. So I can just add 100 to my midpoint over and over again instead of redoing that formula. So if I add 100, it'd be 949.5, then 1049.5, and you kind of just double check that's halfway between those two numbers. 1149.5, 1249.5. Okay, so there's all my midpoints. That is going to help us get started with our mean. So you take your midpoint times the frequency of that group. So times there are 3 things in that group. And then you take the midpoint of the next group. You times it by the frequency of that group. And you keep on doing that all the way to the end of your table. And then 1,149.5 times 12 plus 1,249.5 times 1. Okay, now be careful. You have to find total frequency. That's what this is. We call that N in that formula. So we need to add all this up to know how many people did they survey. So that's what, 13, 14, 26 plus a 24. I'm getting 50. So 50 people were surveyed. So we are dividing by 50. It has to be the number of people in the survey, which is, remember, these are tally marks. So each one of these frequency values represents an item or object or person that was in the study. Okay. So when I worked out that numerator, because I tried to just work it off on my calculator, I got 52,275. And then I divided that by 50, and that gave me, and I always write estimated on these usually because we are using a midpoint as the estimator. So it's 1045.5. So that's my mean. Okay. We got the mean of the group data. Yay. So that part, once you know how to do it, goes pretty quick. Now I have to kind of rough sketch an area drawing for the median. It doesn't have to be perfect, just need enough to know where I can get all my areas. So I'm putting my values down here. We have the 799.5 is the first one. I want to space them out a little bit. 899.5, 999.5, 1,099.5, 1,199.5, 1,299.5. Okay. All right. So each of those are listed. Now the highest frequency we get is 24. So I'm going to count by, I think I did 3s just because I didn't want to put single count values all the way up to 24. So I have 3, 6, 9, 12, 15, 18. Notice I'm staying consistent with my counting by 3 and 24. Okay, these are my frequencies. Okay, so let's go ahead and make those intervals. So I usually like to do those in a different color. So 799.5 to 89.5 goes up to my 3 height. Okay, and remember that rectangle, that red rectangle, that first bar, it has a class width of 100 because that's the distance between these two values, and it has a height of 3. Okay, the frequency is a 3. That gives me the area for that whole bar. So that's a 300. And then for the 899 to 995.9.5, those two, I have to go up to 10. So just a little bit above my 9. That would be second bar. Going to be 100 is still the class width, but this time the frequency was a 10. So that's going to have a total area of 1,000. Okay. For the third bar, we're going up to a height of 24. So this one's going to have a big area. That one's 100 is still the class width, 24, and that's going to be 2,400 for the area. And then the fourth bar, we're going up to 12. That's going to be 100 times the height of 12. So that's 1,200. And then the last, or fifth bar, the area is still class width of 100 between the interval, and this time the frequency is 1. So it's just going to be 100. So that's actually a really small one down here. So we counted by 3s. Okay, so my total area is adding all those values together. Okay, so if we add those, let's see what we get. 300 plus 1,000 plus 2,400 plus 1,200 plus 100. This is in total area of 5,000. So that means the median is going to be, remember, half the total area. That's going to be the location of it. Okay, not the actual median. I should say the area to the left. But it'll be the location of our median. The area to the left of our median is going to be half the total. So that's going to be 1/2 of 5,000 or 2,500. Okay. Now, why is that number important? That's the number that helps us know how many bars to shade. So if I shade the first bar, I've accumulated 300. If I shade the second bar, I've accumulated 1,300. So if I add 1,300 to 2,400, I'm going to be over my middle. So that means I'm not going to be going all the way into this. I don't know where I'm going to stop, but I'm just rough estimating. We don't know what that is yet. I'm only going to go a part of the way into that final third bars area because we want to make sure we stop at 2,500. Now it might be a little further over. I'm just rough drawing this picture. Okay. So my M location should be somewhere between 999.5 and 1,099.5. Okay. So my formula for the median, we do area to the left, which is 2,500 equals any bars we fully shaded in. So 300 plus 1,000 plus, now this part right here, we need two things. We need a way to talk about how skinny this little shading is. So that's M, your median, because that's going to be beyond the edge, minus the beginning of that entry point. So I'm actually going to make my parentheses a little bigger. So that's minus the 99.9.5. And then the frequency for that, the height of that rectangle, because that little M minus 999.5 only tells you this little distance of the width of that rectangle. Then we would multiply that by 24. Just trying to write it in here for the height. Okay, so let's see if we can simplify this and find our grouped median. So this is 1,300. I'm going to go ahead and, added too many zeros. Going to go ahead and distribute that 24. So I'm going to have a plus 24M and then 999.5 times 24. And I know it's negative because we're multiplying times a negative. That's negative 23,988. Add together the two numbers on the left side. So we're adding the 1,300 to that, or to the right side. I can't talk. So I have 2,500 equals 24M, and then that combined two numbers together was negative 22,688. We add that over, so we get our 24M by itself. So add that to the 2,500. I made it positive first. That's going to give me a left side of 25,188 equals 24M. And to finish and find that estimated grouped median, we divide by 24. So that is 1,049.5. So that would be where the estimated median is. I know it came out exact, but because we were using midpoints, not actual data points that we knew we had for sure, technically any grouped values are always estimates. Okay. All right, so that's the end of this video. Hopefully that wasn't too bad. I will write up the ink for this one, and then that should be enough to get the 10-1, 10-2 homework done.